In this video, we'll start section 2.8. We will look at linear functions, and specifically, we really want to start looking at the slope and the rate of change. So to give you a quick definition, right, it says slope is a measure of steepness, right? So the steeper, the greater the slope, the steeper the incline, right? So I always, and I apologize for my stick figure drawing, but I always talk to students and say, think about working out at a gym and you're on a treadmill, right? If there's no incline, the slope would be 0. But then what if you press the incline button up a few times and now all of a sudden the treadmill, you're walking up a hill, right? So now all of a sudden my slope is positive, right? How positive? Well, the steeper the hill, right, the more positive the slope, right? If my hill is not that steep, right, my slope would be maybe a little bit less, right? So this would be the greatest slope, this would be the least slope, and actually this would be 0 slope, okay? So remember, slope measures the steepness, so think of yourself as walking on a treadmill. The steeper the incline on your treadmill, the greater your slope, right? And then if you keep looking, I notice I see something that says slope is also a measure of a direction. So all of the slopes that I drew above, right, here and here, these are all positive, right? But if I were to walk down a hill, right, let's say I'm walking down a hill, well, now my slope would be negative, okay? So negative slopes go downhill, positive slopes are uphill, okay? So below we're asked to determine whether the slope is positive, negative, or 0. So for this first one, this is negative, right, because it's going downhill. This is 0 slope, right, because it's not going up or down. And this would be positive because I'm going up a hill. All right, let's go to the next page. And there are a few more problems we can do. Again, each of the graphs have positive slopes. Circle the graph with a steeper slope. So remember, the steeper slope means the incline on your treadmill would be greater, right? So I would say, whoops, let me get my pencil tool out. Right, so I would circle letter A, right? That is steeper than letter B. What else do we have? We each have a negative slope, which has the greater, steeper slope. So in this case, I would say letter B, right? The negative just tells me that it's pointing down, but the magnitude of that decline, this one is definitely a greater steepness, right? It just happens to be going down, okay? Below are a few practice problems you should try. Again, I would look to the back of the book to check your answers. Those are good problems to practice, okay? Now it says how to find the slope of a line from a graph. This is important. This rise over run, whoops, looks like I hit a button. All right, so this rise over run is definitely something you want to remember, okay? And then it also talks about slope can be measured as change in y over change in x. So, okay, let's find the slope of a line from the graph, and we're going to either use rise over run or change in y over change in x, right? So if we look at the next page, if I were to give you this graph and say find the slope from the graph, you could say, okay, Mike, how many units did we rise, right, from here to here? Right? We picked 2 points that we can easily identify. So we went up 1, 2, 3, 4, 5 units. So we rose 5 units. And how many units did we run? Right, from here to here is 1 unit. So that's where you see 5 over 1, right? My rise over run is 5. All right, 5 over 1. So the slope would be 5. Next problem. It says find the slope of the following graph. All right, so again, if I can pick 2 points that line up on some corner, it could be here, right? It could be down here. All of these points line up on a corner. I want to say to myself, okay, what's my rise? So my rise is I'm going down, looks like 1 unit, and then I'm going over 10. Be careful. Notice how we're counting by 10s and not 1s anymore. So it's down 1, right? So we're going down 1, and then we're going over 10. So you can see my rise over run is -1 over 10, so my slope is -1/10. Okay? So here are a few practice problems. Maybe you want to pause the video and see if you can come up with a slope for both of these. Okay? I'll do them for you. So again, notice this one we're counting by 10s, right? For rise and my run, it looks like we're going 2, 4, 6, 8. We're counting by 2s, right? So I pick points that line up on corners. So to go up, that looks like I'm rising 10, 20, right? So my rise is 20, and my run looks like it's 4. So my slope would be 20 over 4, but you can reduce that to 5, right? Because 20 divided by 4 is 5. Okay. For graph problem number 4, my rise, again, let's find points that line up on a corner. Here's 1. There's 1. Any more? I think that's it. So it looks like my rise is negative. What are we counting by? 2, 4, 6, 8. So we're going 2, 4, 6, 8, 10. So minus 10. And my run is a positive 1, 2. So I would write my slope as -10 over 2, or simply -5. Right? That's my slope. So m is my slope. Okay. Next, you see we get another definition or a formula for slope. It says y2 minus y1 over x2 minus x1. And this symbol here is called the delta symbol. It means change in. Right, so the change in y, right, y2 minus y1, or you could simply say the change in y over the change in x, right, that's x2 minus x1, right, or you could just use the delta symbol, delta y over delta x. And in fact, right, I wrote all the ways you could say slope, right, average rate of change, change in output over change in input, delta output over delta input, or you could write delta y over delta x. All of these things equal the slope. Okay. And on the next page, they do a really good job of giving you a definition, right? Slope is equal to m, which is your rise over run, change in y over change in x, delta y over delta x, y2 minus y1 over x2 minus x1. These are all nice ways to say slope or average rate of change. Okay, I think I'm going to stop here. Look for part 2 shortly to work through some of the rest of these problems. Thank you for watching.